Hello everyone. Today I will share with you the second part of NEL-ARTS, Planning Intonation under Cognitive Constraints of Speaking, Research Procedure and Analytical Framework. The author conducted this research at the Eye Tracking Lab, the University of Tartu in Estonia, using a key technology called the Gaze Contingent Display System to ensure strict experimental consistency. The experiment had two phases. In phase 1, participants performed a picture description task. They first completed 6 practice trials to learn how to describe characters using structures like A and B. In the main task, they described images with 3 characters while adhering to double actor syntax. For example, the chef and the waiter are carrying boxes. In phase 2, involved a memory language integration task. Participants memorized 3 unrelated words, say apple, key, river, then described the image, and finally judged whether a verb matched the action, such as, is eat appropriate for a carrying scene? In the above 2-item experimental design, time control is crucial here. The authors achieved millisecond-level accuracy. Each trial followed the following sequence: a 500 millisecond fixation across to central attention, followed by a 6,500 millisecond image display, and a 3,500 millisecond response window. The key feature of the timing control is the fixation rule. The system will check whether the participant is actually looking at the center of the screen before starting the timer, which minimizes the main distractor effects and focuses on duration, how long the participant fixates on a specific word area, revealing immediate syntactic processing. If participants looked away prematurely, the trial was automatically scrapped and recycled. This strict protocol ensured reliable data for analysis. There is another item in the author's research steps that we need to understand, which is multi-modal data synchronization and quality control. The experiment recorded audio using prot, transcribed it word for word, and used the BAS system for forced alignment, adding timestamps to each word. Trials were excluded if the speech delay exceeded 3 standard deviations or the pause duration exceeded 500 milliseconds. For eye tracking, only volumes with a duration of less than equal 400 milliseconds and micro movement amplitude of 400 milliseconds were retained. Additionally, F0 was converted to Z-scores to eliminate gender-based acoustic differences. These steps try to ensure these research statistical models accurately capture variable relationships. Let's take a closer look at how this study transforms raw audio into analyzable data. They used prod, which you can think of as Photoshop for speech, to manually mark the exact times when people started and stopped speaking. They also marked instances of disfluency, pauses, self-corrections, or phrases like For example, if someone says, the chef and the waiter are, they flag those hesitations. And they use the bus system alignment tool to automatically and precisely locate word boundaries. However, the machine is not perfect, so they double-checked every word to make sure the time stamps were accurate to within 10 milliseconds. Now, how did the author sync speech with eye movements? Let's break it down. All speech data went into TextGrid files, a Swiss Army knife format storing word boundaries, syntax labels, and even pitch curves. Think of it as spreadsheet, but for sound. The author also tracked noun phrase types, such as the chef versus the chef and the waiter, in separate sheets. For eye tracking, they defined areas of interest, AOIs, based on who did what in the images. If an actor was the doer agent, they drew a box around them plus a 100-pixel buffer, like giving them personal space. Every gaze was classified as agent, patient, or empty. And how did the authors organize the data from this experiment? It's like panning for gold. You have to sift through a lot of stuff to find the nugget. First, the authors used the LMER model and Bayesian statistical data tools. Second, adjust the participants' memory performance. The task was so difficult that participants had to work hard to memorize the words. And more than half of the trials, only 64 of 84 people remember at least one word. Therefore, the study ultimately relaxed the criteria. Third, the eye tracking filter criteria were also relaxed. For speech, only fluent and complete sentences were retained in this study, without incomplete phrases. Now, before the end of today's briefing, let's take a look at Figure 7 in the article. Perhaps you can understand the author's experimental process and analysis methods. These figures shows the differences in the proportion of participants using plural nouns such as centas and coordinated noun phrases such as Santa Claus and the elves across cognitive load conditions. The horizontal axis is divided into short sentences and long sentences, and the vertical axis is the percentage of occurrence of these two structures. Scholars distinguish between low load, no memory task, and high load, single words to be memorized, experimental conditions. First, let's look at the complex structure preference of long sentences. Regardless of load, long sentences use coordinated nouns significantly more often. For example, when describing multiple characters, it is more appropriate to say Santa Claus and the elves are decorating the Christmas tree rather than using the simplified plural form. This reflects that the speaker needs to clearly distinguish the roles in long sentences, so he adopts more complex coordinated forms. And next, let's look at the impact of cognitive load. Under high load conditions, that is, the two groups on the right, the proportion of coordinated nouns decreased slightly, especially in long sentences, and the pink bar graph decreased by about 5% compared to low load, the two groups on the left. In addition, for a short sentence like "The Christmas tree is decorated," the structure choices are not much different whether or not you need to memorize words. Overall, these figures support the core hypothesis of the study, that sentence length and cognitive resource jointly influence language structure selection. When speakers need to process long sentences and their cognitive resources are limited, they make a trade-off between structural complexity and memory load, which is reflected in a decrease in the proportion of coordinated structures. This structural simplification strategy may be related to the cognitive mechanism of human language planning. Well, I think I said too much, which means I didn't digest the content of the article well. You may all be tired, so I'll stop here. See you Thursday afternoon. Take care and bye.